Dear ladies and gentlemen, dear Chairman, many thanks for the opportunity to present our recent research at this meeting. In my today's talk, I'm going to present a child-appropriate multiplex mass spectrometric assay solution, which allows for the reliable monitoring of two major regulation systems, the Renin-Angiotensin-Aldosterone-System and the adjoining Kinin-Kallikrein-System by utilizing low sample volumes. On this slide, you see the common presentation of both systems. On the right-hand side, the Renin-Angiotensin-Aldosterone system. Angiotensinogen is cleaved by renin to angiotensin 1, and this decapeptide is converted into angiotensin 2 by the angiotensin-converting enzyme, which is amongst others a prominent target in pharmacotherapy of hypertension, for example. Angiotensin 2 itself interacts with the angiotensin receptors and also affects aldosterone. The second system, less investigated than the Renin-Angiotensin-Aldosterone system, is shown on the left. In the adjoining Kinin-Kallikrein system, kininogen is converted to bradykinin, which acts on the bradykinin 2 receptor, or is cleaved into inactive metabolites also by the angiotensin-converting enzyme. Endogenous peptides and humoral parameters within these two systems, the Renin-Angiotensin-Aldosterone system and the Kinin-Kallikrein system, play a key role in acute attacks of angioedema, arterial thrombosis, or other cardiovascular diseases like hypertension or heart failure, but also in renal diseases and adrenal insufficiency. Additionally, their involvement in endocrinological diseases like diabetes or neurodegenerative diseases like Parkinson have been described. And further, these systems have been implicated in inflammatory diseases like liver, pancreas, or bowel diseases like morbus Crohn and colitis ulcerosa, but also in respiratory diseases and epilepsy and depression. Although little is known by now concerning these systems in children, it is known that both systems undergo substantial developmental changes during childhood. But especially research during the last years in adults found this system to be much more elucidated and complex, as it is illustrated nowadays in many textbooks. On the right-hand side, we see again the Renin-Angiotensin-Aldosterone system. The rate-limiting step involving renin and prorenin is highlighted in dark blue. One of the effectors, aldosterone, as well as its precursor and main metabolite, are shown in light blue in the center of this slide, while on the left side the Kinin-Kallikrein system is depicted. The small blue boxes indicate the elements of both systems that are commonly reported and which I have shown on the slide before, while all other boxes show peptides or humoral parameters being currently intensively investigated in adults. For example, research results on angiotensin 3 in animals and adults indicate that this peptide might be at least as vasoconstrictive as angiotensin 2. The interplay of this cascade has not been comprehensively investigated in children. An often cited argument is that the required blood volume for such a comprehensive investigation cannot be collected in children ethically. However, an understanding of the interplay among the complex biochemical cascades might either allow relevant insight into the etiology and pathology of the disease, or new insight into the mechanism of drug action. Nowadays, the investigation of those biochemical parameters are often limited by the blood volume that is available. As you all might know, the European Medicines Agency has published a paper on ethical considerations in pediatrics. In this paper, also recommendations on the maximum blood volume that should be collected in pediatrics is given. On the upper right corner, I have arranged an overview what this information means to a newborn or neonate. For example, 3 milliliters at a single investigation for a newborn with a body weight of 4 kgs and 9 milliliters within 4 weeks. Since also in recent pediatric trials, often the same analytical assays as the ones applied in the adult studies were used, it gets obvious why in corresponding pediatric studies often only one pharmacodynamic parameter can be sampled, and this most likely also only once during the whole study period. On the bottom, I have selected 2 ongoing studies in children as an example. And what we get to know from the official text on clinicaltrials.gov is that the here presented pharmacodynamic parameters are sampled once due to the restricted blood volume. But how shall we get better knowledge on the renin-angiotensin system if often only one parameter is monitored in the young age groups, and this is done frequently in a single sampling only? Therefore, innovative and reliable bioanalytical tools are highly required, which facilitates the comprehensive investigation of those endogenous peptides in small human sample volumes. Consequently, we put our effort into the development of a tailored multiplex bioanalytical platform to overcome the aforementioned limitations. The established platform bases on a high-performance liquid chromatography coupled with mass spectrometric detection. This technology is regarded superior, as known limitations, by immunoassays for instance, can be circumvented. A main focus, beside the highest possible coverage of removable parameters into this platform, was the setup with a small sample volume to enable a comprehensive investigation, also by repeated sampling in all pediatric age groups. Its broad calibration range ensures its application to healthy and diseased populations, as most removable parameters alter into the opposite direction if a healthy or a diseased population is investigated. Finally, the platform was established on a high-throughput approach to enroll it into clinical studies, and the latter is also promoted by the fact that the platform is fully validated according to international agency requirements and embedded into a good clinical laboratory practice-compliant environment. Thus, a tool was established that supports maximum knowledge gain from human blood samples. And what can now be gained by this ready-to-use platform exactly? This multiplex bioanalytical platform will not monitor only one biomarker or surrogate parameter in a small sample volume, like NT-proBNP in cardiovascular diseases. The system enables a deeper and comprehensive insight into the main cascades and monitors it coherently. In its current extent, it allows for the comprehensive investigation of 7 parameters in the Kinin-Kallikrein-System and 14 parameters within the Renin-Angiotensin-Aldosterone-System. By applying this platform, we will be able to monitor precursors, main substances, as well as their metabolites in low sample volumes. Let me use the slide from the beginning of my presentation once again to illustrate what can be analyzed by the established low-volume bioanalytical platform. All red marked peptides and humoral parameters are enclosed in the current determination. And due to the low total sample volume of 500 microliters, 21 parameters acting in both systems can be analyzed even by repeated determination in, for example, neonates. This platform facilitates the comprehensive investigation in healthy and diseased children without infringing ethical considerations. Moreover, the low sample volume makes it possible to collect blood in children more than once, and therefore empowers researchers to evaluate the maturating Renin-Angiotensin-Aldosterone-System and its adjoining Kinin-Kallikrein-System. So I have shown you the developed and validated multiplex bioanalytical platform, which bases on highly reliable mass spectrometric bioanalysis. It allows for the comprehensive monitoring of two important regulation systems and subsequently enables a deeper, coherent insight into etiology and pathology of cardiovascular, renal, endocrinological, and respiratory diseases. Due to the low sample volume, this system can be applied to all age groups, children, adults, and elderly, without infringing ethical considerations. And therefore, this system might help to identify new promising drug targets, but for sure facilitates better understanding of important diseases. And finally, we hope to further enroll this platform very soon into future research. Many thanks for your kind attention, and also many thanks to my colleagues and co-workers at the Institute of Clinical Pharmacy and Pharmacotherapy in Düsseldorf.